Hi guys, today we're going to look at a couple more examples from yesterday's notes on solving literal equations. And we left off with example 9 yesterday. We're going to start with example 10 today. If you remember, whenever you have a fraction, you want to first clear your fraction. And in this case, our fraction has two terms. So our LCM, our least common multiple, is just that denominator that we have. It's going to be e plus a. So we're going to multiply both sides by e plus a. And what this does is it clears it from the fraction on the right-hand side, and it brings the e plus a to the left. So I have t being distributed into e plus a equals 2u. And I'm solving for a, so I'm going to have to distribute. So I have te plus ta equals 2u. You could also have divided by t. That would also work. And I'm going to subtract te from both sides. So I have ta equals 2u minus te, and finally divide by t. So I end up with a equals 2u minus te all over t. This is one possible correct answer, and if you remember from yesterday, we said that both terms are being divided by t. So this could be simplified into 2u over t minus e, because te over t divides out the t's. So both are correct answers. Okay, and now we're going to look at a new concept, which is factoring out. So sometimes we want to isolate a variable that it looks like it can't be isolated because it's in two terms. So if you look at example 11, we have x that we want to isolate, but x is here and x is also here. It's in two terms, and those terms can't be combined. It's not like you have both of them with px or both of them with fx. So what we do is we use this strategy called factoring out. The factoring out strategy is basically going the opposite way from the distributive property. You set up, outside of parentheses, you set up a distributive property problem. I'm copying d equals, and then that x that I want to isolate, I put it on the outside of parentheses, and I say to myself, what would I distribute into? X times what two terms would give me px plus fx? And what that does is it turns the two x's into just one x that's sitting outside of the parentheses. So I'm going to just recopy that, and I'm going to leave it blank so that you could see the thought process. So x times p would be px, and then x times positive f would be fx. Okay, and again, now that x is just, instead of being in two terms, it's just in one place. So now to isolate x, it's the opposite of multiplying by p plus f. You're going to now divide both sides by p plus f. So once you're here, you now divide by p plus f. Okay, so I'm going to divide by p plus f and divide by p plus f. The parentheses are optional. You could or could not put them. It's up to you. And so our final answer is now x is isolated, d divided by p plus f. Again, parentheses optional. Okay, and again, we use this, going back up to the top, we use this, we factor out to solve for a variable when there are two unlike terms that contain that variable, like px and fx. Okay, and we need the two x's to become one x so that we can isolate it. And so what we do is we put it outside of the parentheses in front. Okay, I'm going to take a look at one more example today, and then we'll stop for today. Example 12 says solve for a. So you might want to pause the video and try to see if you could solve for a. So again, the a is in two places, and I can't combine them, so I'm going to put the a outside of parentheses like this and set up the distributive property. So I'm going to think to myself, a times what two terms would give me am plus a? So a times m is am, and then a times 1 positive 1 would give me back a. And now I can isolate a. Those two a's have now become just one a. I can now just divide by m plus 1, divide by m plus 1, and we're done. A equals 15 over m plus 1. Okay. All right, we're going to stop there for today and use this plus yesterday's notes to help you work on tonight's homework. And I'll see you guys tomorrow. Okay, thanks.